Have you got an inline 4-cylinder with a turbo? Is your fabricated manifold always broken? Today on the Skid Factory, we're going to show you how to minimise the harm. Welcome back to the Skid Factory. This is Gus's Bmw E30 improved production race car. It's currently going through a bit of a makeover, which we're going to be a little bit of a part of, obviously a bit of a paint job and that sort of thing, but we're actually working on it to try and solve a problem that it's always been stricken with during its racing career, and that is to do with manifold fatigue and turbochargers disconnecting themselves from the engine. The engine fitted to the E30 is a Bmw M42 1.8 litre 4-cylinder. It's factory fitted to this particular model in certain specs. The engine's been built for boost. It's originally an NA engine, and it's also been built for purpose as a improved production race car. So the engine itself is a good thing. It does make good power, but there's always a but. It does suffer from things that affect its reliability, and they're mainly caused by the engine vibrations, which all 4-cylinder inlines will cop, and the bigger the engine gets, the worse it gets. So a lot of engines would have balance shafts in to try and reduce this. This engine does not have that, so it's not a thing. So what we're going to try and do is replace this exhaust manifold, which has been on there since the car was built, with something that's going to provide a bit more reliability. First thing to get rid of is this T25 flange. There's nothing you can do to stop those things falling off when you've got these things vibrating at the right frequency. It's like a sonic screwdriver if you're old like me and watch Doctor Who. So first thing we're going to do is get rid of this flange and replace it with a V-band. V-bands don't have gaskets, they don't have nuts and bolts, so the chance of failure from that is much lower. Second thing we're going to do is build the manifold with a pro, and we're going to make it out of the appropriate metal, and we're going to use the right processes to make it and go through that with you. One thing that is also thrown in the mix with this thing is it's got a restrictor in front of the turbo compressor that's required to race in improved production with a turbocharger. So there's a 34mm hole that compressor's got to breathe through. That in itself causes a lot of issues, or can cause issues if you don't work around it. So there's a few things we're going to do to go along with that to help the tuning process to make the engine perform at its best with that limitation involved. If you've been watching for a while, you'll probably notice we do a lot of fabrication on the show, but as with a lot of things, I'm just self-taught and just out of necessity. And sometimes it's cool to get a pro on the show to tell me all the things that I don't know and what I've done wrong. And today's pro is Matt from Goleby's Parts and Fabrication. He is the fabrication manager there. So how did you get into this welding things together gig?
I did a mechanic apprenticeship because I wanted to build cars. I got offered a Fab apprenticeship. Yeah, no. I learnt that all I did was service cars, so I got offered an apprenticeship at a sheet metal workshop. So I took that, left my apprenticeship behind, and 11 years later, just sort of taught myself working on my own cars and my mates' cars. So it's good to be able to do it every day now for Goleby.
So it's probably relevant to note that just like being a race car mechanic, you don't start as a race car mechanic, you start as a mechanic. And same with fabrication. If you want to fabricate race car stuff, you've probably got to start at the other end of it. So Matt would be making handrails and just general fabrication, and that's where you learn your skills. Then you can apply your skills to race cars, and you're much cooler then. So we've got a bunch of pipes and stuff here, Matt. What are we going to do? How are we going to make this the best manifold that ever was?
So the stainless here is actually it's a 347 grade, so it's good for high temp. It's also a little bit thinner, so what we're trying to do here is reduce the weight, so using a different rear housing on the turbo, which is irrelevant anyway, but that should reduce the weight, also the piping, because these things like to rattle and break things. So
it's no 1JZ.
No 3RZ, but similar. So yeah, Al's called us to come out and give him a hand, so yeah.
Where do we start?
Well, with the flange, we're going to have to get the flange straight because usually they get laser cut and they warp, so we'll get that straight and then we'll get it into the car, work out our turbo position, and then get the collector and hopefully make the first runner pretty smoothly.
Yep.
And then once we go from there, we can sort of half mock it up on the bench.
Yep. That sounds kind of like what I do, except I don't straighten the flange. That's probably instead I've learned something straight up.
Yeah, so.
All right, let's go get that flange straightened and go from there.
Easy. So basically, as soon as they go blunt, you want to sharpen it because the arc will tend to wander. That's the whole reason for the sharp point, and also the way you sharpen it, because all those grooves, when you blow it up through a microscope, so if all the grooves are going sideways, this can make the arc wander a bit. Because we're purging, I've just had to seal it up, so I'm using the tape because it's high heat resistant. So it's polyester tape. They use it for powder coating. It's just got a high temperature, and then the foil's also just to try and block it. Like low in there. It's not getting anything done like getting plumb back in, is it? It's going to go over screen pipe. Is there a certain regulation with where it's got to exit? Because it might be easier to put it on the front of it.
Just put it. Fits as badly as I expected.
So the flange was cut to suit 1.5 inch, like a standard 1.5 inch pipe, but because the material we're using is 347, it's actually a different size ID. So what we've had to do here is make something work. So that's why we've got custom reducers that we've made to suit the port, which will port match. Yeah, sometimes this is just what you've got to do. Yep.
You are good at that.
I thought you said V-bands are easier.
What happened there?
Welder. The fans are blowing the gas.
We've got the first runner tacked on to both flanges. The turbo position is good. However, we are now discovering after all the bracing and everything's out of the way that there is some problems with runner clash. So the closer that turbo is to the head and the closer or the further forward it is, the more difficult it is to get the runners around each other. And then you also got to consider, how do I bolt this thing back onto the engine as well? That can be an issue. So what we're going to do is, well, what Matt is going to do is you just use that first tacked up runner as the manifold, like the brace, to show that's the turbo position. Then we'll work out how to do it while we're there, and then start at the other end. Then that one will probably just get cut off and it'll be rerouted. This is why they call it fabrication, because you just got to make it work.
And how do you like BMW 4-cylinder so far, Matt?
Well, I don't like them any more than 3RZs. These are probably worse. There's less room.
It's like a CA18, but it broke its other leg.
Yeah. The beauty is I don't have to see it run, because I've heard that it's a bit shaky. Max amperage that is coming out the torch.
Yeah.
That's your base amp, so that's on the opposite end of it. So basically it says up, down.
And then you said pulse or something before, that's all. You mentioned pulse you changed.
Yeah, so that's hertz. So this is how many pulses per second. So yeah, so at the moment it's 111, so it pulses very quickly, quicker than you'd be able to see with the naked eye. So basically all it does is try to take the heat out of it.
Fabrication is a pretty broad term. It could come down to weld process, the material you're using, the environment that the product that you're making has got to be used in. And I think automotive fabrication is a very niche thing, because we need to have all those skills of welding and cutting things up and piecing it all together, but we've also got to understand what environment this particular thing is going to be under, as in heat and cycling of heat and that sort of thing. So it is something that you do learn on the job. Matt is obviously an experienced fabricator in both general work and also in automotive, but each job that you do, it is going to be different, unless you're just repeating a process and building manifolds off a jig or whatever. So the first time making something like this, it's going to be time consuming and sometimes a little frustrating. So we're just going through the process. There's nothing fast about it, so keep your patience and chill out. Where we're at the moment is we've removed this number 1 runner, because we've now got number 3 and 4 runners. Matt's welded them all out after we've pieced them together, which is, again, time consuming, and we've got them tacked on. So now they're the captain now, they're holding the flange, so the turbo's in the right position. We have refitted it to the car. Now the engine needs to be jacked up every time we put that manifold in, which is an annoying BMW thing. But it does fit in place. The turbo's in the right spot, so we're happy with that. Now we've got to go about fixing up these number 1 and 2 runners. I had a couple of questions for Matt, as a guy that's taught himself how to do this sort of stuff. I did it by looking at pictures of things and going, yep, that's what it should look like. weld. Yeah, okay, that works. Long process. But having Matt here, who is actually trained to be a welder, I'm going to ask him a couple of questions that you'll probably want to know as well. So the first one is, you'll often see this entire manifold tacked together. It looks complete, but there's no welds on it. There's just tacks. Are they going to just weld that whole thing up as it is, or are they going to pull it all back down to pieces and weld it separately?
So ideally they'd cut it all apart and weld each runner individually, because what you want to do is you want to try and reduce the amount of distortion you have. So if you had this all tacked together and you welded it, you can't really control what it's going to do in the end. At least this way, we've welded each runner, and if we have to tweak it slightly, we can, and then basically leaving the last welds to the very end. You know, distortion's a huge thing, and a lot of the time it's just either from experience or having a go and see what happens and how it turns out in the end.
So 1 mil of shrinkage or movement one way or the other on each one of those welds is going to change everything. And as well as this possibly moving inwards or outwards, this flange, it might be flat when you've got it bolted down, but if you weld that thing out in one bit and undo that, it'll probably just go twang and it'd be bent like a banana, because the metal is a very strong force and you've got to work with it. You can't control it, you've got to just work with its movement.
You mentioned shrinkage too. How much shrinkage would you see on a runner like that?
Generally, like I find that with a weld, it might shrink 0.5 mil to 1 mil per weld. Depends on the material. Stainless likes to shrink more. Aluminium, not so much. Steel, the same. But stainless just seems to eat it, and yeah.
Yeah, so as pretty as stainless is and how nice it looks like to work on, it's actually a lot more difficult to work with than a mild steel. It's harder to weld. You've got to do the right thing when you weld it. Otherwise, it's of no advantage whatsoever. Like Matt has been incredibly careful about the purging process, setting up the welder, making sure that there's the right amount of penetration internally, and you wouldn't have to do that with mild steel. It's much easier to work with. So a lot of the stuff you'll see is made out of mild steel, and because it is a good material, but in this application it is a race car, so we're going to the extra effort to make sure this process goes correctly, and then you will get a better result from it.
When the weld, even these tacks, when they're hot, the shielding gas is there to stop them from oxidizing, because oxidation isn't the best thing for stainless welds. It creates carbides and they can fail and crack because it goes brittle. I think obviously the reason why the other one was braced so much was just the position of it, so I thought if we have less hanging weight, like a cantilever, be less prone. But then obviously you're dictated by this.
Yeah, also you drain, oil drain and shit.
Oh yeah.
This can be
10 degrees or whatever.
15, I think, off center.
Yeah.
We just jacked up the motor and refitted the manifold. All the runners are welded out and it's all tacked together, so it's ready to be welded once this wastegate goes on. It's a GFB EX44, nice and compact with a lot of flow through that valve. Matt's concerns with an external wastegate are don't hang it too far away because there's a thing called cantilever effect. So the further away that is from the, and also the turbo of course, the more leverage there is on the actual flange of the head and all the runners. So we want to keep it as close as possible. So we've got to work out where it's got to go. And we've also got to, as at the same time, allow for oil drain, mostly oil drain. That's probably the thing that's going to need to be snaked around it. But that's pretty standard with most turbo setups.
Yep. So we finalised our wastegate position. It's still going to be tight, but it was one of those things that we had to put it there. I'm just about to start welding this thing out. We've got a purge going into this first runner here, so we're just currently waiting for it to build up. You can work out some math behind it, but we're just sort of give it a minute and a half. Just going to be starting from the bottom here, and then I'll work my way up to the top. Obviously, once I get to the top here, I'm going to have to change this out with some alfoil, just because it's going to get a bit hot. So yeah, hopefully it all turns out, and hopefully when we unbolt it, I've got to stop saying hopefully, eh? When we unbolt it and it's not a banana.
There's the finished product. It's looking good. It's still bolted down. It's still cooling from the welding process, so it'll be left bolted to this until it's cooled off to minimise any warpage that might occur. It's probably relevant to note that this is quite a time-consuming thing to build, and it is for a actual race car. So it's been built from materials that are suitable for the application. You normally would not need this 347 material for a road or drag, or like most vehicles, it's more of a sustained high speed, high heat sort of thing. So you're probably better off just buying an off the shelf manifold if it's available for your car. If you've got a, I don't know, a Toyota Crown wagon with a Barra, you just buy a 6-boost manifold for your G40. That's a better idea. They're proven work, quality's great, and they are an absolute bargain compared to what this costs to custom produce. So we kind of just wanted to make this video just to show you what is involved in something like that, so you've got a bit of an idea of what you're getting yourself into if you want to get something custom made like this. So turned out great. We're happy. Matt's a gun. We'll unbolt that thing and bolt it back on the engine, and we'll probably have to make a manifold of a dump pipe of some sort tomorrow, and we'll go over that as well. Matt's got to get back to work. He's snuck off for a couple of days, so
Got to crack some whips.
yeah. Well, he's got to get back to work and manage the team. So thanks a lot for coming, mate.
No, thanks for having me.
Appreciate it, and thanks for answering all my stupid questions about stuff that most people probably think that I know, but I don't, because self-taught. Thanks a lot, mate.
That's all right.
we're done with the BMW for the moment. I've just made the dump pipe and a little screamer there. So what we're going to do now is actually pull the whole engine and gearbox and everything out, and it's going to go to get the rest of the paintwork finished. So once it's done, we might go to a track day or something with Gus and see how he goes. To recap, the reason why we did this is because this was having multiple failures in the exhaust manifold and also in the turbocharger itself. It's actually been through a few turbos before. This one is actually new. It's only been used once. So what we've done is change the exhaust housing, get rid of the 4-bolt flange and the 5-bolt outlet. So it's all V-band now. It's V-band underneath as well. V-bands are much more reliable. There's virtually nothing to go wrong with them. There's no bolts done except for that one. And they just work. Been used in trucks and race cars for 40, 50 years before we've suddenly had them become available to us. So they're a good thing. When Angus asked me about fixing this for him, I could have just done it myself and just as a favour to him, but I wanted to get a pro in just to see the differences in the way that I've taught myself to do it and the way that a pro who does it all the time has been taught from day one with no preconceptions. Like, he would have been a grommet when he started working as a fabricator, and he would have just done what he's told, and he would have been taught by a guy that was a lot older than him who probably went through the same process. So it's good to see the way that I should have learned how to do it, and there definitely are disadvantages to self-teaching yourself, and advantages as well, I suppose. But yeah, it was good to see how Matt did everything. Notably, the actual material that he chose to use was not what I expected. I am aware of the 347 material, but it's kind of not something I've ever used. So it's interesting to know that there is such a thing out there that is specifically designed for actual motorsport, not just for Instagram and look and bling in your engine bay. So it'll be great to see how this goes. I'm pretty confident with it. The work, I mean, it looks amazing. It's a welded manifold. They always look nice if you're into that sort of thing. So once we get it back on the road, or it'll come back here once it's painted and everything, I'll put it all back together, fix all this stuff that we're going to have to change. It's obviously got an intercooler and intake and that's got to be sort of hooked up, and we'll add some extra sensors. We're going to monitor turbo speed, because this restrictor, when it comes into play, if you don't play along with it and realise that it's just going to restrict the intake and there's nothing you can do about it, if you try and keep boost pressure up, the turbo actually overspeeds, and that's what the failures were from. So there's a certain tuning strategy that goes along with having a restrictor in place. This sort of thing is widely used in most motorsport that's got turbochargers involved. It's just basically to level the playing field so you don't go crazy with your turbo selection. And it definitely works at leveling the playing field, but it also has a lot of things that go along with it that you need to understand if you're going to tune an engine that's got a restrictor on it. Got to give a huge shout out to Matt and Christian from Goleby's Parts and Fabrication for coming down and getting involved and showing us how it's done. Those guys have got a big fabrication workshop up there in Toowoomba. There's a good crew working all day, every day, making awesome parts. Ranges all the way from JZS 171s right up to Porsche, Audi, some of the more high-end stuff. So good development program going on as well, and all Australian made. I'm not sure they do anything for BMW M42s, so probably don't ask. I don't think Matt wants to look at it again until they fix the broken engine mount problem and straighten the engine up a bit. That's all we got. Thanks for watching, and we'll see you next time.
That's all, folks. Yibbity yibbita.
Yibbity yibbity.
Wait, hang on. What did Bugs Bunny say?
Yibbity yibbity. No, it wasn't Bugs Bunny, was it?
That's all, folks. Yeah, it was.
No, it was like the bumbly guy, the hunter guy, wasn't it? I don't know.
What's his name? Archibald or something?
It was like in 1935 or something that they made those cartoons.
It's about as old as you.
Yeah. Story, bro. Old as your hair.
Old as Steady's hair.
It's better than yours.
They're like twins.
It's like older than you too, bro.
What? By 2 months?
Is he? Oh, is that all?
Something like that. I'm sure we're the same age.
He looks better than you.
21.
Better nipples. All three of them.
So we got the professional in Al. Just a side man.
Is this your side guy?
I'm just standing in his fart.
What if the truth comes out that Matt's actually not
Qualified?
qualified? He's just also self-taught. Oh yeah, I just used to watch lots of the Skid Factory.
Yeah. Yeah. No, well, this stuff is, a lot of it is kind of self-taught still, because even in a production setting or where you, like, you do your apprenticeship, it's very different. Like, unless you're doing the same thing day in, day out. My apprentice at work, he's super lucky because he does day in, day out stainless welding, aluminium welding, so he's an absolute gun. He's probably done more welding than I did in 6 years of my trade in a year. So, and that you see it in the results, and he's just a gun. So, plus he's naturally gifted, I'm not.
But he might not be that good at making a gate or a truck body though. So
yeah,
it's
that's right. That's right.
That's what the gasless MIG's for at home.
Yeah, which is true, because it's like, yeah, if you had to do like something square, something round, like every new job that I've had in the industry, it's always been different. So, yeah, if you want to get into fabrication, you definitely need patience.
When you said Toyota Crown, I thought you were going on the
Toyota Crown Barra.
I thought you were going on the JZS 171 thing. I was like, then who will put a Barra in a Crown wagon? I was like, oh, wait a second.
Derp.
Oh,
Yeah, that's me.
Who would? Some idiot.